Hey kids, what's up? Well, we are doing our last exercise. So in the course outline it says we have to do one I, then there's one after that, solving graphically, but it's not in our textbook, so I'm assuming this is our last exercise. So after this one, make sure you do the chapter review and a practice test, and then we'll be testing eventually. Alright, this exercise is perpendicular and parallel lines. So, copy down the notes first. Remember, pause it, copy down all the notes, and I'll fill stuff in and explain it in just a minute. Alright, let's start. So first thing you've got to remember is parallel lines mean that they run side by side, like train tracks. They never cross over. And perpendicular lines cross over at right angles like that. So perpendicular lines cross each other, parallel lines run the same way. So, key thing, parallel lines have the same gradient. They've got the same slope. For instance, if we look right down in this graph here, these two lines here are running side by side like train tracks. They have the same gradient or the same slope. So any two lines that have the same slope or the same gradient are parallel lines. Same thing here, look at these equations. Remember, y equals mx plus c. So hopefully you know that here the gradient is minus 2. So it's the number in front of the x. And this one here, the gradient is minus 2. So both of those gradients are the same. So therefore these two equations are parallel lines. We do not care about the y-intercepts. It's like this. These have different y-intercepts, but they're still parallel. All we care about is the gradient of each line. Hopefully you're good with that, everyone. Let's move on. That's the easy bit. Perpendicular lines. Like I said, they intersect at right angles. So there's a couple of round little formulas here that I'll explain. Gradient of 1 times gradient of 2 is equal to minus 1 for perpendicular lines. I'll talk about that in a second. And if you rearrange it, divide both sides by m1, you get the second gradient is equal to minus 1 divided by the first gradient, which says here, gradient 2 is a negative reciprocal of the first gradient. You're probably saying, what does that all mean? All this means is, if you get the two gradients of perpendicular lines and multiply them together, they should be equal to minus 1. If they don't equal minus 1, then they're not perpendicular lines. Let's just do some examples that might make things a bit easier. So here's the example anyway. This line here, it goes in that direction. Don't know exactly what the gradient is, but it says here that they intersect at right angles. So therefore, these two lines are perpendicular lines because they intersect at right angles. And that's the theory of this whole topic. So, before we move on, I just want to show you an easy way. You can use this formula if you're given one gradient to find the perpendicular gradient. But I've got an easy way for you. So, if the first gradient is 4, for instance, remember up here how I said the second gradient is a negative reciprocal. Okay, reciprocal means make it 1 over, or you flip it upside down. So, and you make it positive or negative, you change the sign. So if the first gradient is positive 4, the second gradient we flip it, so we make it 1 over 4, and this is a positive, so you make it a negative. That is the reciprocal, or the perpendicular gradient. So if the first gradient is 4, the perpendicular gradient is negative 1/4. Does that make sense? This is on the top line, it's like 4 over 1, so you make it 1 over 4, and this is a positive, so you make it a negative, you change the sign. So you do two things. Let's do the next one. If you've got a gradient, the first gradient is 7. First thing is, that's 7 over 1. So you flip it, you make it 1 over 7, and that's a positive, so you make it a negative. It's as easy as that. Let's try another one. First gradient's negative 5. That's the same as 5 over 1, negative 5 over 1. So you flip it, so it's 1 over 5, and that was a negative, so you make this one a positive. You don't need to put the plus sign there, but I've just done it just to emphasise it's a positive. And the last one, negative 2/3 is our first gradient. So we flip it upside down, so our gradient is 3 over 2, and it was a negative, so you make it a positive. So these two are perpendicular gradients. So that's all we have to do. Or if you wanted to, you could use this complicated formula, but I've just shown you a really easy way to do it if you remember that. Alright, let's just do examples and hopefully it'll make it a little bit easier. Alright, decide if these lines are parallel. That means they've got the same gradient. Perpendicular, that means that the second gradient is a negative reciprocal. Remember that, you flip it and change the sign. Or if neither work, then you say it's neither. They're just going to intersect at some random angle. Alright, so when we have to answer this question, the only thing we care about is the gradient. So let's look at these lines. This gradient here is -3. I'm going to write it. The gradient of 1 is -3. Can you see that? This gradient here is a third. The gradient of 2 is 1/3. So let's have a think about this. If we look at the first gradient and we flip it, make it 1/3 and change the sign to a positive, yes, it works, it's 1/3. So we know that these two must be perpendicular. Perpendicular. Can you see that? Because the two gradients follow the rule that I just explained. Another way to check is if you multiply these two together. Remember this formula over here. Multiply the two together, they should equal -1. Let's do that now. So we've got -3 times by 1/3. Let's see what they equal. These two 3's cancel and just leave 1's. So the answer is -1. So we know that that those two lines are perpendicular. Let's try the next one. Y is equal to 1/2 x plus 2. So we know this gradient is 1/2 because we can read that straight away. Now the next one, it's not in the right format. We need it in y equals mx plus c. So we have to rearrange this equation to make y the subject. So yes, we have to actually do some work before we can see what the gradient is. So we'll get y by itself, or plus x to both sides. So we get x plus 5. And now we divide both sides by 2. So we get y equals x over 2 plus 5 over 2. Now x over 2 is the same thing, it's saying it's 1/2. So I'm going to write it like this, 1/2 x plus 5 over 2. Can everyone see that? X over 2, you can bring it out the front and make it 1/2, because then we can see what the gradient is. So now we can see that the gradient of this one is 1/2. And what do you notice? They're the same gradients, so these two are parallel. So I'll just go over that again. This one we could read off the gradient straight away. This one we had to rearrange it until we got y by itself, and then we could read the gradient off and see that they're the same, so they must be parallel. Excellent. Let's do the last one. The last one, they're both not in the right format, so we're going to have to do a little bit of work here. So let's do the first one. 3x plus 2y equals -5. I'll do this a little bit quickly, is year 8 maths. So minus 3x to both sides, minus 3x minus 5. Divide everything by 2, and we get minus 3 over 2x minus 5 over 2. So we can see what our gradient is right there. It's minus 3 over 2. Let's do the same for the next one. X minus y equals 2. So we'll get rid of the x, so we get minus y equals minus x plus 2. Now to get y positive, you need to multiply each term by the negative sign, -1. So this becomes positive, and this becomes negative. So what's our gradient here? There's really a 1 in front of the x. So our gradient is 1. So this time we've got, our gradient is minus 3 over 2. This one's 1. So neither rule, they're not the same, and they're not the negative reciprocal. So this one would be neither. Good job, everyone. We're just going to do a couple more examples. So copy all that down. Thanks. Hi guys, thanks for coming today. Alright, so let's do some tricky questions. And this is our last exercise, so bear with me, do this, and you'll be great at the test. So it says here, find the equation of the line that is parallel to this equation and passes through that point 1, 9. So remember, there's two things we need to find an equation of a line. What are they? Yep, that's right. We need to find the gradient and we need to find the y-intercept. Remember we did that in an earlier exercise. Great. So, Let's have a look at this one. First thing, it says it's parallel to this equation here. So parallel means that they've got the same gradient. So all we care about this equation is the gradient. We know the gradient's -2. So we need a gradient, our gradient is going to be -2 as well, because it says it's parallel to that equation. Does that make sense, everybody? It's the first easy step. So great, we found the gradient. Good job, guys. Now all you have to do is find the y-intercept. Unfortunately, they didn't give us the y-intercept. If they gave us like 0.9, that'd be awesome, when we're done. But unfortunately, they gave us a random point. So what we need to do to find this value of c, the y-intercept, we're going to use the formula y equals mx plus c. Alright, so we've already got the value of m, we're going to substitute into there, and we're trying to find what c is. So we need an x and a y value. Where do you think we're going to get that from? Let's look up here. Whoa, there's a value there. There's a point. That is our x value and that is our y value. So we're going to substitute those values in to this equation. So then we've got our x value, then we've got our y value, work backwards and you've got c, and then you're good. So let's substitute all those values in. Y is 9. 9 equals -2 times x, which is 1, plus c. Can everyone see what I've done? I've substituted y in. Y is 9. M is -2. And x is up there as 1, and then it's plus c. So solve this. 9 equals -2 plus c, plus 2 to both sides. You get c is 11. We've now finished all the hard work. Now we just have to substitute those into y equals mx plus c. So y equals mx minus 2x plus c plus 11. And we are done. How do we get that? We got the -2 because we knew what our m value was, and there's our x value, so we put that in there. That was pretty easy, that one. Let's try the next one. Alright, it says, find the equation of the line that is perpendicular to this equation and passes through that point there, 3 minus 2. So again, the only thing we care about in this equation is the gradient. The gradient of that equation is 3/4. I'll write it down here. M1 is 3/4. But the gradient that we want is perpendicular to that. So our gradient we want is perpendicular. Hopefully you remember from 5 minutes ago, how do you find the perpendicular gradient? You flip it upside down, so you make it 4/3, and you change the sign. This is a plus, so our sign is a negative. So the gradient that we want is -4/3. So that was our first step. Good job. And again, we've got a point here which is 3, -2. That's our x value and that's our y value. So what do? We substitute them all into y equals mx plus c, which is a generic formula for the equation of a straight line. So y is -2 equals m, -4/3 times 3, which is x, plus c. We have to solve this. Hopefully you remember times in by 3 and dividing by 3, they cancel. So that was convenient. So we've got -2 equals -4 plus c, plus 4 to both sides. So be careful. -2 plus 4 is 2. So c equals 2. And we're finished. That wasn't too hard, was it? First step, they gave us a gradient. We had to flip it and change the sign. They also gave us a point, so then we had to substitute everything into that equation, work backwards to find the value of c, and we're finished. So now we write our equation, y equals mx plus c. Remember that? So y equals, m is -4/3 x, and our c value is 2, plus 2. And that's as hard as it gets, everyone, so if you can do that, replay the video if you don't understand just yet. I'll give you a chance to copy down those notes in a second. Okay, now I'm pretty sure we're finished for the whole chapter. It did say in the course outline that there's a graphing exercise, but our book doesn't have any exercise on graphing, so we'll get back to you on that. Assuming that's the end, everyone, I want you to finish off. There's our exercise for 1i. Then of course, I want you to do the chapter review. Remember, just pick the questions that are relevant to our topic. So go through the 4 exercises we've done. Then hopefully we'll give you a practice test before the real test, and then we'll all be good. So get back to me if you've got any questions. Hopefully that made sense, and see you next time.